In today's video, we're going to go through area and volume. So these are sort of the key formulas. So for area, you have of a circle, you have pi r squared. And then for the circumference, it's 2 pi r. For square or rectangle, it's just length by width. And then perimeter is 2l plus 2w. Flipping over the page in your formula tables, you have the volume of a cylinder, which is pi r squared h. Think of the base as a circle, and then you're just multiplying it by how tall it is. Next, you have a cuboid, so that's just length by width by depth. And then you have the volume of a sphere, which is 4 over 3 pi r cubed. Just make sure in your formula tables, when it's talking about volume, it has A, but that's surface area rather than area for 2D shapes like a circle. So a few examples covering volume. This is from a paper. We have a block of wax that has dimensions 45, 35 and 10. To find the volume, we just go 45 times 35 times 10, and that will give us 25,200, and its volume, and we're using centimeters, so it's centimeters cubed. Using this wax, they're going to make candles, so find the volume of the candle in terms of ore. The volume of a cylinder is going to be pi r squared h, so that's going to be pi r squared times 9, because we don't know what ore is, and that will give us 9 pi r squared. If one block can make 100 candles but 10% is wasted, what is the candle's radius? So we know 10% is wasted, so only 90% is actually usable. So to find that, the usable volume, we're going to do 25,200 times 0.9 to get 90%, and then divide that by 100 because we're finding each candle and there's 100 candles. That will give us 226.8 centimeters cubed. So this is the volume for each candle, but we also know this is the volume for each candle. So equaling them, we're left with 226.8 equals 9 pi r squared. We're going to divide both sides by 9 pi to get rid of it, and then square root to get rid of the square root. And then we are left with 2.83 centimeters, and that's a normal measurement, so we'd sort of take that as correct. On to the next. This is another example from the paper where it's on about balloons and pumps. So we have a pump here where its height is 20 and it has a diameter of 6. It's a cylindrical pump, so we're going to use pi r squared h. The diameter is 6, so the radius is 3. So it's going to be pi on 3 squared times 20, and that will give us 180 centimeters cubed because we're using volume. Next, we're pumping a balloon and it has a radius of 15. So what is its volume? We know the volume formula is going to be 4 over 3 pi r cubed, and our ore is 15, so it's 15 cubed. Gives us a volume of 4,500 pi, and in the question they ask you to leave it in pi. Next they say, how long does it take to pump? So we know we're trying to pump 4,500 pi centimeters cubed, but each pump of our pump gives us 180. So it's going to be 4,500 pi all over 180 pi. That gives you 25, and then it tells us one pump equals 1 second, so it's 25 seconds. Next part, it says, if it takes 50 seconds, how big is the balloon? So if it takes us 50 seconds, we know it's going to do 180 pi times 50, because that's our pumps times how long you have, and that gives you 9,000 pi centimeters cubed, and that is the volume of the balloon we're going to inflate. But we also know volume is equal to 4 over 3 pi r cubed. So this is the volume of a circle, or this is the volume of a sphere. This is the volume of the sphere we're trying to find, so we can find ore. Next, we're just going to equal them. So it's 4/3 pi r cubed equals 9,000 pi. Pi's are going to cancel because they're both sides and they're multiplying by everything. Then we're going to divide by 4/3. Or to get rid of our cubed, we're going to do the cubed root. So or is going to equal 18.899 centimeters. To find area, typically the hardest one is when you're minusing one from another. So here they tell us the shaded area is 6 meters squared, and they're asking us to find y, and they tell us that x is equal to 3y over 7. So I know the area of a triangle is going to be half the base by the height. So in our small triangle, the area, I'll call it S, is equal to half of the base, which is 3, on the height, which is x. And then the area of our big triangle is going to be half of 3 plus 4, which is 7, on y. To find the area of the shaded region, we're going to take the area of the big triangle and minus the area of the small triangle. That will give us half of 7y minus half of 3x. But this equals 6 meters squared, as told in the question. But we know x is equal to 3y over 7. So we can sub that in to get everything in terms of y. To make this simpler, I'm going to multiply both sides by 2 to get rid of the halves. So we're left with 7y minus 9y over 7 equals 12. Taking the y's out, we're left with 7 minus 9 over 7 equals 12. Y will equal 40 over 7, 2.1 meters, because the area is in meters. So that's an overview of area and volume. It's more just knowing what formulas to use and then just subbing in either you're using or you're finding or. And these are sort of simple to do well in.